Welcome. I'm Dan Torello with the Kluge Center at the Library of Congress. The title of today's program is Artificial Intelligence and the Search for Life in the Universe. With us to talk about these issues are Sara Imari Walker. She's a theoretical physicist and astrobiologist and associate professor at the School of Earth and Space Exploration at Arizona State University. Also with us is Caleb Scharf. He is the director of the Astrobiology Center at Columbia University, where he studies cosmology, exoplanetary science, and the search for life in the universe. Moderating their conversation will be Susan Schneider. Susan is the William F. Dietrich Distinguished Professor of Philosophy at Florida Atlantic University and the founding director of a Center on the Future of Mind. For the past year, Susan has also been the Barrick Blumberg NASA Library of Congress Chair in Astrobiology in residence at the Kluge Center. This program is a collaboration between NASA and the Library of Congress, and it's designed to focus attention on the societal dimensions and implications of the search for life in the cosmos. Susan is a philosopher of consciousness and of mind, and one of the questions she's been investigating is, what would it look like if we were to find that other minds in the universe are actually post-biological in nature? So these are the questions we're going to be hearing more about today. Caleb, Sara, Susan, thanks for being with us. And Susan, over to you.
Hello, and Dan, thank you for the kind introduction. I've had so much fun this year at the Kluge Center and working with NASA and the Library of Congress. And I'm so thrilled to be talking with Caleb and Sara today about a constellation of issues involving artificial intelligence, the search for life, and more. And with that said, what I'd like to do is just quickly start the discussion with a question for Sara. Sara, it's a very easy question. I'm just kidding. I want to know, what is life?
Oh, lovely. Don't we all? I want to know what it is too. Yeah, so I think, people have thought about this a lot of different ways, but for me, it really breaks down to what problems we haven't been able to really answer from a fundamental perspective yet. So physics has been really good at describing, the behavior of elementary particles and the large scale structure of the universe, but I think it hasn't come anywhere close to predicting things like living things or thinking things. And really part of the huge conceptual gap there is related to the fact that living entities and anything that life produces really is a product of information and how information operates in the physical world, or at least that's sort of my perspective on it. So when I think about what life is, it has to be associated somehow with the fact that information actually is a real physical thing, can really physically exist in our universe, and has consequences. So the thing that's kind of exciting there about thinking about what life is if you kind of take this approach that there are certain objects in the universe, like my water bottle, that require an evolutionary information processing process to produce them eventually, you get kind of a new conception of life in terms of, when life emerges in the universe, it's this process whereby information starts structuring matter across space and time, and that becomes this evolutionary process that creates all of these subsequent structures. And so that's sort of what I think about when I think, what is life? Origins of life is the transition to this kind of physics where information matters, and the evolution of life is that expansion of that process in space and time to take over more and more matter and do interesting things.
Interesting. And so on that rough definition of life, I suppose artificial intelligence would be a form of life.
Yes. It is definitely a form of life. So I know I just gave my water bottle as an example of life, which I always do, but it's actually just because it requires information to produce it. But there are also things that are alive, which are information processing entities like ourselves that actually do this kind of process of actively using information. And I think artificial intelligence is definitely on that spectrum of things that are life or produced by life. And so, yes, they are alive.
So that really makes me wonder, and this is to Caleb, what is out there? Tell us about the search for life, beginning with the, exoplanets and talking about microbial life, and then perhaps a little speculatively, what about intelligent life?
Yeah, well, listening to Sara, it also made me think that in astrobiology, the quest to find life elsewhere, we almost have a more naive, actionable kind of definition of life, which I think is a subset of what Sara was talking about. We think about, how do we know that there's life on Mars or in the atmosphere of Venus or on an exoplanet around another star? And we ask much simpler questions. So, the interesting thing about this field of looking for life in the universe is how much it's changed in the last 25 years. 25 years ago, we didn't know that there would be many planets, if any, around other stars. We now know that to be, we now know that there are essentially planets around every star in the universe, and a significant fraction of those may be potential harbors for the complex information processing chemistry that we associate with life. To speak to your question about, how close we are to finding stuff, I'm not sure. I wish I knew when we were going to find irrefutable evidence of life beyond the Earth. It may be that we find something in our own solar system. And the interesting question there will be whether or not it's related to us in some way, whether or not the process of life happening in this one little corner of the universe is all interrelated. That it's, the origin event here, spread across multiple worlds. Mostly what we look for these days is microbial life, or evidence of life having manipulated its environment in some way. And what's interesting about that is that it does actually extend to the question of more intelligent life, in as much as there's a resurgence of interest in the idea of technosignatures. So on one hand, we talk about biosignatures, those actionable signs of evidence of life on other worlds in terms of chemical alteration in the environment, but increasingly we're also interested in so-called technosignatures. And again, this meshes really beautifully with what Sara was talking about, this conception of the underlying secret source is information and self-propagating information that fills available niches in the universe by restructuring matter. And technosignatures are restructuring of matter. So like Sara's water bottle, or if we place satellites in orbit, or we put solar panels on our planet, those would be construed as sort of technosignatures. So in my field, there's actually a lot of interest in now not just looking for signs of microbes out there, but looking for technological signatures, repurposing of matter in aid of, let's say, intelligence, for want of a better word.
Fascinating. So, it's a tricky issue, isn't it? It reminds me of when I talked to Seth Shostak over at SETI about, how do we look for post-biological intelligence? If the next civilization that is closest to us is, say, vastly older and vastly smarter than us, which very well could be the case, how would we even find a technosignature that predicted, that was predictive, that wasn't just a reflection of our, minuscule technology? And he said, well, the intellectual difference between us and them could be like the difference between us and, our pets, a goldfish, for example. So what kind of a technosignature could we humble beings even hope to find?
Is that a question for me? Or for Sara?
It's a question for both of you. Whoever wants to jump in.
I can start.
Sure.
I think, part of the challenge is we know what we know, we don't know what we don't know. And so a lot of the basis for looking for technosignatures comes out of pretty fundamental notions about, for example, energy use. So for instance, the famous thing called a Dyson sphere, which is this idea that at some point, if a civilization grows sufficiently, continues actually with the sort of growth rate that we've had for another few thousand years, it would get to a point where it would require so much energy that you would actually have to restructure your energy capturing apparatus. For example, in the form of a Dyson sphere, which is an assembly of structures capturing more and more of the energy coming from the sun or any star. structures like that have to obey the laws of thermodynamics. And so one of the things we look for is evidence of essentially waste heat. You cannot utilize energy without producing a certain amount of, for want of a better word, waste heat, infrared emission. And so people have seriously looked for that as one possible signature. Sara may have other ideas as well.
Yeah. I think something that's underappreciated is that a lot of the same problems that plague technosignatures also plague biosignatures, which is that we just don't know what we're looking for. So there's kind of this implicit assumption we have that we're going to recognize life when we see it, or we'll recognize technology when we see it. And the truth of the matter is we don't know what those things are. I think that's one of the reasons that I'm really motivated by this idea of trying to think more about the abstract principles underlying what life or intelligence is. And from that perspective, and this kind of more theory-driven approach that we're trying to take thinking about physics of information, really what you want there is objects that don't have a natural explanation, right? Like they can't be described as spontaneously forming by the laws of physics and chemistry. And some of the examples that Caleb was citing, I think, would fit in that kind of definition, that you just wouldn't expect naturally like energy to behave this way. You
wouldn't expect a Dyson sphere.
Yeah, exactly. But the question is, how do we formalize that? Because Dyson spheres are obviously things that we've imagined, but like, what about all the things we haven't imagined? And so I think that that's sort of the real challenge that we need to face with technosignatures. And one of the places I think about that is actually to think about molecules as biosignatures or technosignatures. So one thing is like there are some, some things that the universe just can't produce even in terms of chemistry, and it might require getting all the way to technology. And so how many steps is it to actually produce that kind of molecule or that kind of object in the universe? And could you say that that could happen in a finite number of steps by chemistry, or it requires some system that actually knows how to build that, like it has the algorithm for assembling that object? And so that's sort of one approach that you can take based on this informational perspective to try to do this more agnostically, but it's a huge challenge.
Actually, if I might just jump in, another thought came to me, which sort of relates to questions of machine learning and artificial intelligence. I think both of us have been saying that one of the problems is, not knowing what we don't know, and how do you recognize stuff that's completely outside of our experience and isn't even a simple extrapolation from our own technology. Well, at some point we might have machine learning that it may not be super intelligent or anything as dramatic as that, but it could in principle examine the universe around us in a way that has fewer preconceived notions about what it's looking for. You basically have it program itself on what it sees and try to make sense of what's out there. Conceivably, then, it's not a human mind that will succeed in finding something truly unexpected out there. It might be something like a machine that has so potentially fewer preconceptions about what it's looking for.
That's fascinating. What about microbial life? I mean, if you were to guess, like, what would we find first, if anything, in the search for life? You probably wouldn't say that it would be intelligent life. Am I right?
I would say not necessarily. I think, a lot of people want to argue that you're going to find microbial life first, but I think it's a question of like how abundant is technological versus microbial life, and how hard are the steps to get both of them. So there's this kind of issue that we don't know the likelihood of the original life happening, and we also don't know the likelihood that once you get an original life event, say that original life is always biological, that you're going to get intelligence evolving. So those are two hard steps associated with these two different kinds of life that we want to look at, right? But then the other sort of flip side of it is which is going to be more readily recognizable, or which is going to be more widespread. And so there's sort of this assumption that since microbial life comes before technological life, it should be more widespread. And therefore we should be able to find it more readily. But it might be the case that once you have, say one intelligence transition to technological life, it is so super intelligent that it readily spreads in the universe, and its observational signatures are so more readily apparent to us that it's actually an easier target, even though it's a much rarer event. So I think you have to always weigh sort of like, what's the likelihood of detection versus what's the likelihood of this thing existing in the universe. And I think jury's out on that one, but I'm interested in what Caleb has to say too.
Yeah, no, I actually agree with that. I think we do have this sense that microbial life is somehow easier to happen in the universe, and that may be true, but our identification of life, our sort of unambiguous identification of life, may be much harder for something like microbial life. And we actually are facing this challenge in exoplanetary science. People are looking at potential chemical signatures in the atmosphere of exoplanets. It's a fingerprint of the existence of a biosphere. But the truth is, even if we find evidence of oxygen and methane and sulfate compounds, will we ever be able to convince ourselves 100% that what we're seeing is life? Whereas if you talk to an alien, you're pretty sure that's an alien. And so in that sense, as Sarah said, it's this fascinating sort of these overlapping functions. There may be lots more microbial life, but it just actually, in my opinion, may be harder to convince ourselves that we've really found it anywhere. Whereas a talking, walking alien is a whole different story.
That's fascinating. I mean, I've thought about Robin Hansen's great filter argument. And, we certainly don't know at any point of the filter, where it's going to be really, really difficult for life to continue. I mean, it could be that microbial life itself is fairly rare, or it could be that technological civilizations have all sorts of catastrophes. We just don't know. And, it could be that we don't even know what we're looking for when we're looking for life, because we have a very small n approach based on one case, the case we know of. But there's a sort of universal code, if you will, some sort of way of civilizations to communicate that happens when civilizations hit a certain level of intelligence. And of course, that's highly speculative, but I mean, I think it's definitely possible if you ask me as a philosopher. Now, what I'd like to do next is I want to kind of get perhaps a little bit even more speculative. So to go back to, Sarah's initial discussion of what life is. Sarah, you have a sort of information-based focus on life that's really fascinating, because it's easy to connect your approach to life to your, theories of intelligence, for example. And so what I'm wondering, Caleb and Sarah, because I've known Caleb for years and we've talked about consciousness at the Institute many times. I'm wondering, clearly all forms of life aren't equal from a moral standpoint. One thing interesting about the evolution of intelligence, at least in biological systems, is that the most sophisticated biological systems are also conscious. It feels like something from the inside to be there. Mm-hmm. But that may just be a kind of rule with biological cases, or at least cases on Earth. And, if civilizations do become post-biological, they will no longer be biologically based. And it makes me wonder if intelligence, as it evolves, even has conscious experience. So I'm wondering, I'm just trying to get a reaction to that from both of you.
I want to let Sarah go first.
Yeah, I have a lot to say on that issue. I work on consciousness too, but I think the issue is not, so people always want to focus on this notion of the subjective aspects of consciousness, but I think the issue from trying to formulate physical theories is, does it matter to like the reality external to something if that thing is conscious or not? And so from this sort of informational processing perspective, I think there is something that consciousness gives to the dynamics of physical systems that other like non-consciousness can't do, which is to like have imagination and realize things that haven't existed and then actually perform the kind of algorithms in the physical universe to make those things real. So one example is just, you know, humanity as a whole, like imagine things like rockets and planes long before we ever built them. But those are real physical consequences of the fact that we have internal representation in our minds. So my personal perspective on it is that consciousness is a manifestation of the physics of life, which is the physics of how information operates in the physical world. And that other intelligences and things will have to abide by those same kind of physical principles. So you might get some odd quasi-intelligent, quasi-lifelike things that don't have internal representation, but they would probably be, like if you're thinking about life and intelligence on a spectrum, kind of like low-level intelligences or low-level information processing systems, and that most of them, especially if they were going to be an open-ended evolutionary process, would require something that we would associate with consciousness in the fact that they can internally represent abstractions and then use those to do things. Yeah, so that's my 2-second theory of consciousness in the universe.
I can't compete with that. Yeah, I mean, I think it's an interesting question of where you place. I think consciousness in the pantheon of things. And I think Sarah, probably like myself, you know, with physics background, one sees it as a potential solution to certain environmental pressures. It opens up niches for, you know, for life forms to expand into. You know, what's interesting to me is, you know, evolution on Earth, you know, does as well as it needs to in any given moment, right? Species aren't evolving to some predetermined perfection. They, you know, if it works, great, because it often costs more to develop greater complexity. So that's be really a good reason for doing that. I wonder in the universe at large whether, you know, consciousness is ubiquitous, or it's just one of those things that happens in certain niches where it gives that extra little advantage. It enhances propagation odds into the future. So, you know, there could be a lot of what I call savant entities, especially post-biological savants, that are really good at replicating and spreading between the stars, for example. But that is about it. They're not necessarily conscious unless that provides them some additional advantage. Maybe it doesn't. You know, maybe the ability to imagine and to recognize you're observing from within doesn't always help you that much. You know, maybe big data crunching savants are actually the things that rule the universe.
Well, I just have one comment on that, which I think is kind of an interesting thing, because I always wonder about whether the fact that we have internal representation is necessary to doing science in the first place, or physics. So would they even be able to write down like the laws of motion, which is an abstraction, or do mathematics if they didn't have internal representation?
Yeah, I think that's a really fascinating question.
Yeah.
Yeah, because it also, you know, those laws, right, are essentially derived from imperfect measurements of the world, and somehow it's like there's something about our imagination, our internal representation, that lets us overlook all the flaws and connect the pieces.
I chime in as a philosopher, even though I'm just the question and answer person today.
Of course.
So I think that computers have internal representations. And so I think if there are savant systems or super intelligent computers, they will have representations, but that's a different issue than consciousness, at least for most philosophers. So consciousness is that felt quality of experience. Like, you know, when you smell the aroma of your morning coffee, when you stub your toe, it feels like something to be you. Internal representations, they're easier to achieve, if you will. But of course, there are some philosophers like John Searle who would disagree with what I just said, because he felt that consciousness was required for a system to understand or represent the world. But that is, I think it is a minority view. Right. So I guess for me, there's a real question there about, will sophisticated, super intelligent AIs, you know, whether they be here on Earth or elsewhere in the universe, would it feel like anything to be them? Because I do think, contra Sara, that we can already see all around us sophisticated computation that's not conscious computation. So a great example is that most of what the brain is doing at any given moment computationally, like in terms of its information processing, is actually not conscious, sadly. Or maybe we don't want all that minutia, Although it'd be better for science if we could introspect how the visual system works, for example, and all the little algorithms. But I mean, our brains are amazing. Mm-hmm. But all that computation, I mean, only a smidgen of it is even accessible to consciousness. So that's an example right there. And AI, it's not going to evolve in accordance with Darwinian evolution. There'll be evolutionary constraints, but they won't be Darwinian.
Yeah, I don't think I was necessarily taking a Darwinian perspective on it, but I think there's also this issue that we confuse computation with like what happens in physics. So computation is an abstraction that we use to describe systems. It's not necessarily what the system is physically doing. And I think there's and this is part of the problem with consciousness also, we think about it as an abstraction and we don't know how to think about it physically. And so I think all of these things are just really, they seem mysterious because we have ways of talking about the world that are not necessarily the world, and we haven't really come up with ways of sort of merging those narratives in a convincing way where it's really the physical system doing the information processing and it's not just like a slapped on description. And I think those things are fundamentally different. It has something to do with like the difference between like Turing's abstract notion of computation and von Neumann's idea of universal construction, which was trying to embed that that abstraction in a physical way, but he didn't actually get even far enough to connect that with physics proper. So I think we're a long way off from actually answering any of the questions that you were talking about, Susan. But I think you raise a lot of really good points. But I think that feeling that you have is a real physical feeling. It means you exist and you're not a simulation. So it doesn't mean that other things like simulations can't physically exist, because I think you're a physically instantiated simulation and that's why you feel that way.
That is mind-blowing, isn't it? And it's just too bad we're not around each other to actually hash this out for a amount of time, because we've had fun in the past.
Yeah.
Right. Now, our audience will probably want to know a little more about the great filter idea, because they're probably trying to figure out, this idea about at what point it could be difficult for life to emerge. And so I'm wondering if either of you could talk a little bit about the great filter argument, maybe Caleb, since, we haven't given you as much time. We probably...
I'm not sure about that. I probably had more than my share. The great filter is very interesting. And I guess there are a number of ways of describing it, but the way I tend to think about it is in the context of this thing called the Fermi paradox, which goes back to the physicist Enrico Fermi back at the dawn of the space age, who essentially just made the observation that in principle, if you have anywhere in our galaxy a species emerge anytime over the last 13 billion years that has the capacity and interest in moving between the stars, then it's had plenty of time to get everywhere by now. Even moving slowly between the stars. And so the question is, then where is everyone? Right?
Hiding from us?
Well, yeah. So there are many potential solutions to this. So the premise is that we have no real evidence of other life or having been visited. I mean, I know it depends on who you talk to, but I think most rational people would say there's no direct evidence. And so there is this paradox is a little bit strong, but there's a puzzle, right? Because it's either telling us that life is incredibly rare and that technological life is so extremely rare that it actually hasn't happened yet in our galaxy, or there's something that prohibits it. And related to that is the great filter idea, the idea that at some point, any sufficiently sophisticated species that spreads across its planet, much like us, hits a wall. There's something that just prevents it from becoming a true interstellar species. And you can, there's a checklist of things you could add to that. And an interesting sort of slant on that argument is that then it actually would be incredibly depressing to find evidence of life, say, on Mars. And the idea is that suppose you find evidence of life on Mars that has a completely independent origin from us. It doesn't matter if it's still live or if it was there in the past. That increases the likelihood of life having happened all over the place around our galaxy, which then says that it should have definitely been the case that somewhere in the last 13 billion years, there would have been another species capable of interstellar transport and going everywhere. It reinforces the notion that there's a great filter and that we are on the wrong side of it because there's something that just prevents true interstellar spread from any species. That's basically the great filter.
Oh boy, it's always good to think about this during the pandemic too, don't you think?
Yeah, well, it adds another box to that checklist of possible filters.
Yeah, but it is a fascinating idea. So perhaps one way to conclude then is I want to know if you had to place your bets on how to solve the Fermi paradox, what would you say?
Well, I've actually done work on this, and some colleagues and I have done simulations of the spread of interstellar species, and one possibility is actually kind of simple, that it's just that they're out there, but they're kind of clustered. We call it an archipelago model, that based on our knowledge of astrophysics and the way stars are distributed in our galaxy and they move around the galaxy, there are going to be regions of our galaxy just better for this, better for interstellar civilizations to spring up. And we're probably not in one of those regions. So that's it's a Weasley way out of it by saying.
Could you elaborate, why aren't we in one region?
Well, that would be the speculation that we're not in one of those regions, so that perhaps it's a little more sparse. The motion of the stars makes it less likely for transition from star to star to star and so on. And part of the basis for that, you can actually say, well, there's no real evidence that any time within the last 1 to 10 million years that Earth has been visited, shall we say, by a technological species. Beyond that, it's actually very hard to say. You can actually, by looking at paleontological data, it's very, very difficult to know what was going on. But that 1 to 10 million year window definitely places us in one of these sparse regions, if this picture were to be correct. But it also says that we now know where to look in the rest of the galaxy. So that's kind of the, stay tuned.
Oh, wow. And we could shoot back to Project Starshot, which we had a little project on.
Yeah, maybe. I mean, more in terms of, picking up our telescopes and our...
Sarah, what would your answer to the Fermi paradox be?
So mine's like the sort of really trivial one that we don't know what we're looking for, but I mean that in kind of a deep sense, like in the sense, like, humans have been looking at the night sky for thousands and thousands of years, and we never noticed gravitational waves, for example. But it required some really deep insights into the nature of the universe in order to even start looking for gravitational waves and then eventually to discover them. And I think we are just so primitive in our ability to theorize and think about life that we're in sort of like pre-general relativity physics with respect to finding something like gravitational waves, with respect to finding life and intelligence. So obviously I would say that as a theorist that wants people to invest in theories for what life is. But I think we need better frameworks for guiding research, and that's not it sounds like a trivial thing, but it's not really a trivial thing. Like, it's really necessary in order for us to detect life, in my view.
Fascinating. And, in a way, both of you could be right, because there could be clusters and we just don't have an idea of what those techno-signatures would be, because we need a sort of paradigm shift, or we need to enhance our own intelligence so that we could even think along the lines of a highly advanced civilization. Although, to go back to Caleb's point earlier, I mean, there do seem to be some hard constraints on computation, with heat, for example. And, it seems like even in our humble predicament, these are the kinds of constraints which seem very real.
Right. But you could always argue that they go to doing some like quantum computation in like deep interstellar space where it's nice and cold, and then they just don't get much radiation or something. This is sort of the long-term fate of post-biological evolution. So I think it's like any argument you give, you can get around in some way. But yeah, it's a hard problem.
Well, the debates continue, and today just gave the listeners, a small chunk of the kind of debates we have when we talk about the future of life and intelligence and consciousness. And I just want to thank you very much for talking with me today. It was wonderful to have you.
Thank you.